Thank you. Okay, bigger on top. So example. Okay. The degree, right? The biggest power on the top is 2. The biggest power on the bottom is what, guys? 1. So 2 is bigger than 1. Right? So this is a button problem. Okay, a button problem, what it stands for is, if it's bigger on the top, N stands for no HA. Okay, we have no HA. Now, I told you at the beginning, if we have one, we don't have the other. So if we don't have this one, you might think, well, that means we have an OA. Not necessary, maybe. Okay, so we're going to put, this means we maybe have an OA. On the second part of the notes, I'm going to show you how to determine that maybe for sure. Okay, but right now I just want you to know maybe. Maybe there is, maybe there's not. Okay, I want this to be clear as water. Okay, so are we good? Is anybody confused so far? Good, good. Okay, let's keep on going then. The last one. I heard if you took Mr. Gregory last year, I heard he did BOBO and button, but not Betsy. Have you heard of Betsy? No? Okay, so this one's new, okay? Betsy. Okay, now let's think about common sense here. Just combination-wise, we have bigger on top. We have bigger on bottom. What's the only other possible combination we could have? Equal, okay, equal. That way, I'm trying to show you that way you don't have to just memorize. Either has to be bigger on top, bigger on the bottom, and the only other scenario. If you notice, out of the 3 acronyms, that's the only one that has the E, right? E for equal. Okay, E for equal. And with that, so we could say the bottom is equal to the top. Okay, so only other possible combination. Example of this. Are we still recording, Shelby? Okay. Thank you. Okay. Now, guys, be careful in this case. These are equal, not because of the plus ones. Okay, not because of that, right? Because of the powers. That's why they're equal. Does that make sense? Okay. Okay, so we have to give you a few definition reminders. Does anybody here remember what we call a number that's next to a variable, next to a letter? So like this one, it has a name. Anybody remember? Somebody said it. Coefficient, good. So let's talk about this coefficient. It's important. Okay, it's important that we know this. Why? Because that's what this C stands for here. Coefficient. Okay. Now let me give you a little trick question. Is there a coefficient on the bottom, on the denominator? Okay. There's not one that we can see, right? But what happens when there's no number here? It's a 1, right? So we do have a coefficient of 1. Okay, so this is a coefficient, and that's an ugly one. We're good? Does that make sense, guys? It's a coefficient top. Okay, now let me give you another scenario here. Let's say you had 3x cubed minus 4x squared plus 1. Okay. So together, is 3 a coefficient? Yes or no? Yes. Is 4 a coefficient? Is 1 a coefficient? Okay, so we're good, right? So we understand. So this is a coefficient. That's a coefficient. Now we need to expand our definition to say now there's something called a leading coefficient. As the name implies, leading, in the front. Okay, so not just any coefficients, but they have to be in the front of the equation. So this right here is in the front, that right there is in the front. So those are not just coefficients, but they're leading coefficients. Does that make sense? Okay, so right here, which of these two would be a leading coefficient, 3 or 4? 3, okay, so 3 is a leading coefficient. Does that make sense, guys? The difference, leading, okay? And why does this matter? The acronym is really just BETC, but we could call it BETLC because it's the leading coefficient, okay? So here's what it means. So if it's a BETC, okay, what this means is that the HA equation is going to be Y equals the ratio of the leading coefficients. Okay, which sounds really complex, right? But it's not. Check this out. So what are my two leading coefficients for this equation? The 2 over 1, right? There's your equation. Y equals 2 over 1. 2 divided by 1 is really just 2, right? So Y equals 2. So graphically speaking, okay, at 2 on the y-axis, I have a horizontal asymptote. Does that make sense, guys? So there's BOBO, button, and BETC, okay? We still need to do oblique, but before we do oblique, let's practice these first. So that's going to lead us to the next section, part 3. We're going to do HA examples. Not hard, okay, not hard. You just have to know the process. Who is who and how do you find stuff. Okay, so number 1, 5x to the 4th plus x squared minus 4, 2x to the 4th plus 3x squared plus 1. Okay, here's my question to you. Okay, I just want you to identify, is this a BOBO? Is it a button? Or is it a BETC? And then give me the HA. Okay, I'm going to give you guys 1 minute. Okay, 1 minute. So is it a BOBO? Is it a button? Is it a BETC? Yes. For this? Oh, I'm going to show you. That's the next part of the notes. Yeah, yeah. Is that enough time, guys? Okay. So, Shelby, is this a BOBO, button, or BETC situation? BETC? Okay. Okay, BETC. Why is it BETC? What were you looking at? What are the two things that you were looking at to determine that it was a BETC? Yeah. Okay. So remember, what I want you to remember about BETC, guys, is just the E equal. Okay. Remember, that's the one that is equal, right? And so we look at our two leading coefficients. Okay. And so our HA is equal to those two leading coefficients. So 5 over 2, which is really just 2.5. Okay. So graphically speaking, on a graph, that one is located not 1, between 2 and 3, right? 2.5 between 2 and 3. Okay, be honest with me, okay? That way we can adjust to you. How many of you got this correct? Raise your hand. Okay, good, good. So we're about 80%. Let's get it to 100. Let's try number 2. Okay. Again, we'll do 1 minute.